All right, so we are going to pick up with the notes where we left off yesterday. Looking at graph number 3, piecewise function. So first part is 2x plus 5. I'm only interested in it between x is -6 and -2. So I can make my xy table. And in my xy table, I'm going to put -6, -5, -4, -3, and -2. I'm going to plug in my values. So -6 times 2 is -12, -12 plus 5, -7. When I plug in -5, I get -5, -4 gets -3, -1, and 1. I notice right off the bat that all of these are closed dots on this first one. So I can go ahead and plot these points over -6 down -7, closed dots. -5, -5, -4, -3, -3, -1, -2, 1. So that is the first part of my graph. Now I'm going to go to the 2x squared minus 7. I'm going to make my xy table. These are all going to be open dots because I notice that I don't have the equals to sign underneath here. I'm only interested in x between -2 and 1. So -2, -1, 0, and 1. When I plug these in, so if I plug in -2, -2 squared is 4, 4 times 2 is 8, 8 minus 7 is 1, and I get 2 minus 7, -5, -7, and -5 again. And I'm going to plot these points over -2 up 1, this time it's an open circle, -1, -5, 0, -7, 1, -5. 1, -5 is open. I know that this is a parabola, x squared, so I know that this is going to be a U shape. I'm only interested in that part of the problem. And then finally, I am looking at the -4 minus x. I'm only looking at x between 1 and 3. So 1, 2, and 3. These are closed. So -4 minus 1 gives me -5. -4 minus 2, -6, and -7. So 1, -5, closed. 2, -6, 3, -7. That's that part. So now we want to look at domain. Remember that domain of my x value. So I look at the smallest x value of my graph is -6. It's included, so it's bracket -6. It goes all the way over here to my -2 that was open, but my next parabola, right, I have the closed in there. I'm sorry, the first line was closed, but the second one was open. Since I have a closed, it's still included, so I continue on over here. The same thing with the 1. I have an open, but then I also have a closed, so that's included. So then I go out to 3. So from -6 to +3 is my domain. My range are my y values. My lowest y value on the graph was -7. It's included, so it's a bracket. And I go all the way up to the 1. The 1 is also included at one point, so -7 to 1. My interval is increasing, decreasing, constant. So start at the left-hand side, so from left to right, this graph is going up. It's increasing, so it is increasing from -6 to -2. The parabola, the first part is decreasing, so it is decreasing from -2 to 0. And the rest of the parabola is increasing, so I have to come back to increasing. We put a skinny U, which means union or and, is increasing from 0 to 1. And then my line decreases from 1 to 3, so union 1 to 3, and never constant. So then we want to go to the next one, example number 4, do the same thing. Okay. Here I just have 3, so this is like y equals 3. So this is a horizontal line, but I'm only looking between -4 and 0. I have an open dot here and a closed dot here. So -4 up 3 is open, 0 up 3 is closed, so that's the first part of my graph. -x, if I make my xy table, I'm only looking between 0 and 2 for x, so 0, 1, and 2. So I get 0, -1, -2. These are all closed. So 0, 0, 1, negative 1, 2, negative 2, and that little segment there. My 3 minus x, my xy table, I'm only looking between 2, 3, and 4, and these are all open. So 3 minus 2 gives me 1, 0, negative 1. So over 2, up 1, open, 3, 0, 4, negative 1, open, that little segment there. So now I want my domain. My smallest x value is negative 4. It's an open circle, so it's parentheses, negative 4. I come all the way out here to 0, picks back up, goes out to 2, picks back up, goes to 4, not included. So negative 4 to 4, not included. Don't know why we changed colors there. Okay. So now my range of my y values, my smallest y value is negative 2. It's included. So bracket negative 2. I jump up here to positive 1, not included. And then union, I jump back up to 3, but I don't ever go anywhere. So I just have one number. It's just a bracket by itself. Now I want increasing, decreasing, and all of that. So this very first one from left to right, that is constant. That is remaining constant from negative 4 to 0. So I know constant, I'm at negative 4 to 0. Then this next two, both the other two from left to right are decreasing. So from 0 to 4, 0 to 2 we're decreasing, and we pick back up 2 to 4. So from 0 to 4, we are decreasing. We never have any parts that are increasing. So the next thing that we had to talk about and learn how to do was how to write a piecewise rule from a graph. Basically, now they give us the graph, we write the equation, the different steps. So step number 1, notice the different pieces that make up the function. Determine the domain for each piece. Use the points to determine slope if you can, and write the rule. So let's look at the first one. What is the rule that describes the piecewise defined function? Notice I have 3 different pieces. They are all line segments. To make it easier so you can see what I'm talking about, I'm going to label them A, B, and C. And then here I'm going to write my segments. I'm going to write the domain and the slope. And we're going to fill this out. This is going to help us come up with the equations. I have segment A, B, and C. If I start with segment A, the domain is from, let's see, this is a negative 2. It's from negative 2. So my smallest x value, my domain for the A, I'm starting at negative 2. So we are at negative 2. My next x value, so that goes from negative 2 over to 1, it says. So my domain is from negative 2, which is included, up to 1. The slope of that line, so I can either do slope formula, y2 minus y1, or I can count my slope, right? If I do my slope formula, I can look at, I have this point here, 0, negative 4, so 0, negative 4, and the point 1, negative 1. My slope formula, remember, is y2 minus y1, x2 minus x1. So my slope, I can say negative 1 minus negative 4, over 1 minus 0. So negative 1 minus negative 4, so that becomes 3 over 1, or 3. So we have a slope of 3. My next one, B, okay, my domain, I have closed dot from 1 to 5. So bracket 1 to 5 bracket. The slope, again, I could do the slope formula, right? Or I could count, right? If I look at slope formula, 1, 4, 5, 8. We're looking at 8 minus 4 over 5 minus 1, so 4 over 4, which is 1. And finally, C, okay, my domain goes from 5 to 8. They're both included. So 5 to 8 brackets. It's a horizontal line. Remember from Algebra 1 and geometry, a horizontal line has a slope of 0. So now I need to write the equation of each of these. So the piecewise, so f of x equals, we need our big bracket to include all the pieces. I'm going to start with A, right? It's a line, right? So remember, a line looks like y equals mx plus b. We found that our slope was 3. I see my y-intercept is negative 4. So 3x minus 4. Now I have to give the domain restriction over here. We found it up here, okay, so negative 2, it had a bracket, so then I know it has the equals to sign, so less than or equal to, x is in the middle. And then I have parentheses, so it's just going to be x is less than 1. That's the first function. Now the second one I go on to, okay, I see my slope is 1, so it's 1x, which is x. I need to find out what would my y-intercept be here. Okay. This had a slope of 1, so if I went down 1 over 1, I'm at 3. So my y-intercept is 3, so x plus 3. My domain, bracket, so I'm going to have all less than or equal to signs here. So we were at 1, less than or equal to x, plus, sorry, that was a, yes, that was 1, less than or equal to 5. And finally, the last one, this is just a constant, right? This is the horizontal line, y equals 8, so this is just an 8 here. The domain was from 5 to 8. Again, everything in brackets, so 5 less than or equal to x, less than or equal to 8. That is the rule for that one. Number 2, same type of thing, so I can label this A, B, and C. Segment, domain, slope. A, B, and C. So A, the domain, from negative 3 to negative 2, negative 3 is included, negative 2 is not. It has a slope, down 1 over 1, so slope negative 1. B, the domain is from negative 2 to 1, not included, so negative 2 to 1, parentheses, to horizontal line, slope of 0. C, it goes from 1 to 2, both included. And it has a slope, let's see, up 1, 2, 3 over 1, a slope of 3. So now, sorry, that was a slope of 4. I counted my 1, 2, 3, 4, slope of 4. Okay, so now I'm ready to write the rule, the function rule for this piecewise graph. This very first graph right here, okay, and then my slope is negative 1, so I'm at negative x. Okay? If the slope is negative 1, I need to continue that to find my y-intercept. So down 1 over 1, down 1 over 1 is 0. So it would just be f of x equals negative x. My domain, negative 3, less than or equal to, because it was a bracket, x, and then just less than negative 2 because it was a parentheses. My next one, b, that's the constant, it's y equals 1, so just 1 here, between negative 2 and 1, negative 2, less than or equal to x, less than 1. And finally, c, my slope is 4, so I know 4x, I'm going to continue my slope of 4, okay, so 1, 2, 3, 4 over 1, so that's minus 5 would be my y-intercept. And then the domain, so between 1 and 2, both included. So that is the function rule for that one. The last one we have to look at again, I'm going to say A, B, and C. So segment, domain, and slope. A, B, and C. So A, the domain is this line. I see that it has an arrow, so it's going on and on forever, and then negative infinity. So it comes from negative infinity, and it stops at negative 2, not included. The slope, I can just count points. So from this point, I go down 1, 2 over 1, so it's a slope of negative 2. My next one, I notice it's a parabola, okay? So my domain, I'm starting at negative 2 included. Stopping at 1, not included. I'm not going to have a slope for a parabola, but I can go ahead and talk about the parent function of x squared. What do I notice? It didn't go left or right any, it went down 2, so I see that it was shifted down 2. C, right, as another line, it starts at 1 included, and it's going on and on and on forever to infinity. It's a horizontal line, so my slope is 0. So I want to write the equations of these, f of x is equal to the big brackets. That very first line, I I need to see what would my y-intercept be. I have a slope of -2, so it's going to be negative 2x. If I continue my slope, okay, so down 1, 2 over 1, down 1, 2 over 1, that puts me at -4, so negative 2x minus 4. My domain was from negative infinity to -2, so it's all the numbers less than -2, but not including -2, so I can just say x is less than -2. My next one was the parabola, that all it did was go down 2. So x squared minus 2, but I'm only interested in it between -2 and 1. So -2 less than or equal to x less than 1, since that was parentheses. My last one was a horizontal line at 2, so it's 2. I want from 1 all the way out to infinity, so where x is greater than or equal to 1. So those were the notes finishing off graphing piecewise functions and writing the equation of piecewise functions.